Welcome students. Let us look at the topic, the intersection of a circle and a line. Let us say that you have a circle x square plus y square is equal to r square. Let us say that you have a circle centered about origin and you have a line y is equal to mx plus c. You have a line in slope intercept form where m is the slope and c is the y-intercept of the line. Now, we know that if the line intersects the circle at two distinct points, we call that line as a secant. If the line cuts the circle at exactly one point, then we call the line to be a tangent to the circle. If the line lies beyond the circle, we say that the line does not cut the circle. Now, if you are given a circle and you are given an equation of a line, the question is, how do you determine whether the line is a secant, a tangent, or the line does not cut the circle? So that's the question that we are going to deal in this video. Now, there are two different ways in which you can determine whether the line is tangent, secant, or the other case. The first is point of intersection method, and the second is perpendicular distance from center method. So in the first method, what I try to do is I'll try to find the point of intersection of this circle and this line. If I get 2 points of intersection, that means the line is a secant. 1 point of intersection, the line is a tangent. No point of intersection, the line is not cutting the circle. In this method, if the perpendicular distance of this line from the center is more than radius, then the line does not cut the circle. If the perpendicular distance from the center onto the line is exactly equal to the radius, then the line will be a tangent. If the perpendicular distance from the center onto this line is less than the radius, then the line will be a secant to the circle. So first, how do we find the point of intersection? Simple, right? We take y is equal to mx plus c and substitute in the place of y in the circle equation. So x square plus mx plus c whole square is equal to r square. So if you expand this, you get a quadratic in x. So x square times 1 plus m square, you get an m square x square here, plus 2mcx plus c square minus r square is equal to 0. So you got a quadratic in x. So if the discriminant of this equation is greater than 0, you have two distinct roots for x. If the discriminant is exactly equal to 0, you have only one root for x. That means the line will become a tangent. If the discriminant is less than 0, there are no points of intersection. Hence, the line lies outside the circle. So everything depends on the discriminant of this. So what is the discriminant of this? B square 4m square c square minus 4 times 1 plus m square times c square minus r square. That is equal to 4 times m square c square minus c square minus m square c square plus r square plus m square r square. This m square c square and m square c square gets cancelled. That is equal to 4 times r square times 1 plus m square minus c square. So if d is equal to 0, if discriminant is equal to 0, that means you have only one root. That means there is only one point of intersection. That means the line is a tangent. So r square times 1 plus m square minus c square is equal to 0. This implies c square is equal to r square times 1 plus m square. This implies c is equal to plus r minus r root 1 plus m square. So this is the condition for the line y is equal to mx plus c to be a tangent to the circle. C is equal to plus or minus r root 1 plus m square. And if the discriminant is positive, that means you have two roots. That means the line is a secant. So r square times 1 plus m square minus c square is greater than 0, implies c square is less than r square times 1 plus m square. So c lies in between plus r root 1 plus m square and minus r root 1 plus m square. So if c lies in between plus r root 1 plus m square and minus r root 1 plus m square, then the line is a secant. So secant if this condition is valid, and not intersecting if the reverse condition, right? C square is greater than r square into 1 plus m square. That is, c is greater than r root 1 plus m square, or on the negative side, c is less than minus r root 1 plus m square. So these are the conditions for the lines to be tangent, secant, and not intersecting. So c is equal to plus or minus r root 1 plus m square. Then the line will be a tangent. If c lies in between plus or minus r root 1 plus m square, the line is a secant. If c is above r root 1 plus m square or below minus r root 1 plus m square, the line is not intersecting the circle. So this is one way in which you can analyze, and this is called point of intersection method. Now let us go for perpendicular distance from center method. So next, if you go for perpendicular distance from center method, so if the perpendicular distance from the center onto this line is exactly equal to the radius, then the line will be a tangent. So what is the perpendicular distance from origin onto this line? Mod of c by root of 1 plus m square is the perpendicular distance, is equal to r, implies tangent. So mod of this is equal to r. So c is equal to plus or minus r root 1 plus m square. This is the condition for tangent. You can see that you got the exact same condition by previous method also. Next, if the perpendicular distance is less than r, so mod of c by root of 1 plus m square less than r implies secant. So mod c is less than r root 1 plus m square. So on the positive side, c less than r root 1 plus m square, and on the negative side, c has to be greater than minus r root 1 plus m square. So this is the condition for secant. You got the exact same condition here. And the condition for do not intersect is the reverse condition. Mod c is greater than r root 1 plus m square. Mod c is greater than r root 1 plus m square. So c is greater than r root 1 plus m square, or c is greater than r root 1 plus m square, or c is less than minus r root 1 plus m square. So these are the conditions for a line to be a tangent, secant, or not intersecting the circle. So once you have derived the conditions, let us further analyze the nature of tangent to the circle.